This is our last look at other angle measures, and again, other angle measures means angles that are not central or inscribed. So this is day 3. So let's look at our goal is to calculate the measure of an angle or arc formed by secants and tangents. You have previously done central angles whose vertex is at the center. You've done 2 versions of on, so the vertex is on the circle, either because it's called inscribed or just because it ends up being on the circle. There is a situation where the vertex is inside the circle, and now we're going to look at a scenario where the vertex is outside the circle. So basically you have 4 scenarios. So I'm just going to kind of put a line here, and a line here, and a line here. Okay, so there's 1 central, 2 on, 3 inside, 4 outside. But we have 2 circumstances there. There are actually multiples, but I wanted you to just see these 2 to start with. So again, just as a review, and I'm going to recap this instead of writing down the actual formulas, I'm going to kind of recap it. So a central angle has an angle measure that is equal to its arc. So the angle in degrees is going to be the same as the arc in degrees. If you have a scenario where it is on the circle, it does not matter if it's inscribed or just on the circle, the angle is half the measure of the arc. So the angle in degrees is half of the arc in degrees. And again, it doesn't matter which of these pictures you end up going with, or which of these 2 scenarios you have, that is the same relationship. Inside, because there's 2 identical angles but 2 different arcs, the one angle in degrees is half the sum. Okay? And the sum of what? That's the sum of the 2 arcs. So this arc right here and this arc right here. So the sum of the 2 arcs. So if you kind of look at the pattern, we had the angle is the arc, the angle's half the arc, the angle's half the sum. If we continue with that pattern, then we're going to look at half the difference. And this is now outside of the 2 arcs. It's not falling somewhere between them. So we're going to have to subtract our 2 arcs and take a half. So I'm going to use the letters right here. So the measure of the angle, so angle AGB, is going to be half the difference of the 2 arcs that lie within the angle. So again, this is our angle, what lies within it. Well, arc AB and arc FD. How do I know which one goes first? The bigger one. Well, how do you know which one's bigger? It's the one farthest away from the vertex. That's because your angle is opening up, and as you go away from the vertex, it's going to get bigger. So this scenario right here looks like it shouldn't be that big of a deal, right? I mean, it's pretty much the same thing. It's when we start applying this formula to the type of question, it does get a little trickier, but we're going to look at that here in just a minute. It's still a matter of the angle is outside, so my angle FGD is equal to half the difference. And so this arc, remember, we can't call it FD because FD implies the shortest route possible. So this is arc FAD. So the measure of arc FAD minus the smaller arc here, which is arc FD. So interestingly enough, in the case where it's 2 tangents instead of 2 secants, you're going to end up using the entire circle to do this, whereas here you're only using parts and pieces. So I'm going to summarize these the way I did up at the top. If you're looking at a scenario where the vertex is outside the circle, the arc in degrees is half the difference in degrees. We're going to look for the measure of angle 1. Again, 1 is not a degree value. 1 is the name. And it's not a variable, it's the name. So that's why it's written as the measure of angle 1. So we always start with the angle. So the angle is the measure of angle 1 equals half the difference. So I know I'm going to subtract them because my vertex is outside. Which one's farthest away? It's the 80. And the closest is 32, which makes sense. 80 is greater than 32, so we're going to subtract. So the measure of angle 1 is the measure of angle 1 is half of 80 minus 32, which makes it 48. So the measure of angle 1 is 24 degrees. So you can see it's getting smaller as we come down. So number 2, again our angle's 1 here, so the measure of angle 1 equals half the difference of the two arcs. So I need this bigger arc and I need this little guy. Well, I already know the little one, it's 138. I don't know this one, so how am I supposed to do this problem? I can't have two unknowns. So remember when I said we had two tangents, it's going to be a little different because two tangents use the entire circle. So if you went all the way around, you'd go 360 degrees. Well, so far, I've only gone 138 of the 360. So this arc is whatever's left over from the 138 degrees. So 360 degrees is the whole circle. I'm going to take out the 138 that I know of so far. So this arc is 222 degrees. So now the angle is half the difference of these two arcs. So 222 minus 138. So the measure of angle 1 is half of 222 minus 138, which is 84. So the measure of angle 1 is 42 degrees. Again, you can see that it's getting smaller. So these are really the same questions. They're just asking for x instead of naming the angle. They're putting a variable inside the angle. The vertex is still outside, so the angle still goes first. So the angle in this case is x degrees. It's going to be half the difference of the two arcs. Well, we know this arc is 220. We don't yet know this arc. But it's two tangents. So if we start here and go all the way around, it's 360. I only get 220 degrees of it. So this arc right here is what's ever left over from the 220. So this is going to be 140 degrees. So this is 140 degrees. That arc right there has a 140 degree measure. So we want to do 220 minus 140. So the measure of the angle is half the difference between 220 and 140. 220 is farthest out, it's the biggest, so it goes first. So x equals half of 80. So x equals 40 degrees. Now, all of our examples have been because we didn't know the angle, we didn't know the angle, we didn't know the angle. What happens if you don't know the arc? It doesn't change a thing. You do it exactly the same way. The angle goes first, and it's still half the difference. The arc farthest away is bigger. I guess I didn't need my parentheses to be that big. So the angle 118 is half the difference of 78 minus x. Like our previous lessons, distributing by a half would work here, but did you want to deal with a fraction in front of a variable? Most people don't, so I'm going to do what we've done previously. I'm going to go ahead and multiply both sides by 2. So 36 equals 78 minus x. So we're going to subtract 78, giving us negative 42 equals negative x. Don't panic. It's okay that we have a negative x at this point because we're going to divide both numbers by negative, and x is 42 degrees. I'm going to show that to you one more time, just in case. And that's a secant, even though I didn't make it keep going, which is fine. It can do that. So the angle is 30 degrees. The smaller arc is 20 degrees. What would x be? I've placed the x in a different location, that's fine. And so the angle 30 degrees equals half the difference. And again, the arc farthest away is bigger, so it goes first. So 30 equals half the difference between these two arcs, x and 20. We're going to multiply by 2, which makes this 60, equals x minus 20. Then we're going to add 20, and x ends up being 80 degrees. I know that that one's kind of weird because everything so far has been getting smaller as we come across. What this one's done is this vertex is very close to the circle, and so it does seem a little strange that it works that way. But it does work.